very good afternoon to all my dear lovely students. Welcome to the class of chemistry today. Myself Anirudh Mehta from Shri Chaitanya Gosala. I'm going to discuss the most important topic of physical chemistry. Hello Lavanya. Today we are going to discuss most important topic of physical chemistry. Most of you are confused whether to remember all the formulas or is there a way to derive the formula during the exam. Surely beta, this will be going on, Anjana. We will try to do that. What you are saying for the full syllabus on the YouTube will be covered. Already most of the things are covered in the YouTube. If you go to the playlist section of this channel, most of the topics are covered, and this year also it will continue in parts. So we were coming, let's come back to our topic. See, most of the chapters that you study in the physical chemistry which you find difficult, like mole concept, like stoichiometric calculations, like electrochemistry, like thermodynamics, all these chapters, and including equilibrium. Many of the questions can be solved from these chapters just by one method without learning any formula. So I'll be able to relate with you all these chapters. I will show you how to solve questions from there with just simple unitary method, which all of you use in your daily life every single day whenever you go to a shop. Whenever you go to a shop to purchase anything from the shopkeeper, you use something called as unitary method. You don't even know it, and you are so fast in using unitary method that you do everything calculation in your mind only. Same thing you will do in the form of chemistry. Same to same calculation. In your mind, you can get most of the answers. What is unitary method? Quickly let us once see. If you go to a shopkeeper and shopkeeper say, let's say you want to purchase 15 flowers. You want to purchase 15 flowers, and shopkeeper says, I'm selling a bunch of 45 flowers for, let's say, 250 rupees. A bunch of 45 flowers he's selling for 250 rupees, and you want to purchase 15 flowers. Okay, you will not ask the shopkeeper, Bhaiya, how much money I should give you. You will not do that. What you will do is you will calculate in your mind, okay, 45 flowers, 250 rupees. Meaning, if I 1/3 it, it will become 15 flowers. So you will 1/3 this money as well. You will say, okay, I will pay you 250 by 3, which is 83 rupees. If you pay 83 rupees, you can purchase 15 flowers. I hope it is clear what we are doing here. You are thinking in your mind, 45 flowers is selling for 250 rupees. 15 flowers should cost how much? If I make flowers 1/3, cost will also become 1/3. So 250 ka 1/3 will be the cost, which is 83 rupees. So you will pay him 83 rupees income. This is unitary method. First, understand in a very layman language what you need to do in unitary method. How did we reach to this number 83? What you do is, whatever you know, you keep it on left hand side. So your left hand side, you will keep your known quantity. Known quantity. In this case, number of flowers you knew. Number of flowers you already knew how many you want to purchase. And whatever is unknown, you keep it on the right hand side, which is going to be unknown. In this case, the money was unknown. How much money you want to pay to him, that was unknown. When you went to the shop, you already knew how many flowers you want to purchase, but you didn't know how much money you will have to pay. Shopkeeper told you 45 flowers I am selling for 250 rupees. So you'll say 45 flowers cost 250 rupees. Correct? Unitary method means in your mind you are somehow calculating one flower cost how much rupees. If 45 cost this much, one flower cost how much? Whatever number is there, bring it to the denominator. 250 by 45 rupees. Right? 250 by 45 rupees. This is per unit. You can all do this. It's not at all tough. Whatever the number is there, bring it to the denominator. And then you are trying to purchase 15 flowers. So then you will say 15 flowers cost how much? If one flower costs 250 by 45, 15 flowers will cost into 15, which is 250 by 3, 83.3 rupees. Simple. I hope it is clear to everyone. Say yes or no if you are there in the class and you are listening to this. Say yes or no if this is clear to everybody. Then we'll move forward and see how the most difficult questions of Faraday's law of electrolysis also can be done by simple unitary method. I will be relating all these chapters today. So we'll be covering questions from all these chapters today just by using the simple unitary method. Let's decode our physical chemistry and not mug up any of the formulas and directly go for the concept. Okay, so I'm starting with this now. Let us start with the first type of problems we are taking from the mole concept calculations. In your chapter 1 mole concept, whenever a question is asked, convert mass to molecules, convert molecules to volume, convert volume to number of electrons. Okay, in those cases, what you need to do is just think unitary method. Hi Rahitya, how are you? Good to see you again, Rahitya. One of the most favorite student of mine is here, Rahitya. So calculate the number of molecules in 11 gram of CO2 gas. So whenever anything is asked to you, what is the substance given? Write the full kundali of that molecule. So if I talk about CO2, I will write the kundali of CO2. I'll call it mole concept of CO2. A mole concept means writing everything about 1 mole of substance. Whatever we know about 1 mole of a substance, we can write. Okay. At least what we must know by now is that 1 mole of any substance will contain Avogadro number of particles. Since CO2 is a molecule, I can say 1 mole CO2 contain Avogadro molecules. Okay. 1 mole of any substance always weigh molar mass. Hi Shalini. 1 mole of any substance will always weigh its molar mass, and we know molar mass of CO2 will be 44 gram. Right? We can write 100 more things about CO2. We will concise it to whatever the question is asking. We can also say 1 mole of any gas occupy 22.4 liter at STP. Now let us just look at the question. Question is saying, calculate the number of molecules. NEET asks you these type of question every year. Which of the following option has the highest number of molecules? Which of the following option has the highest mass or more number of atoms? These type of questions every year comes in the NEET. So how many molecules in 11 grams of CO2? You can do it in your mind. Think mole concept of CO2. 44 gram contain Na molecules. 44 gram में I can purchase Na molecules. 22 gram में I can purchase Na by 2. 11 gram में I can purchase even half. Na by 2 का also half. Na by 4. Answer will be Na by 4. So simply we'll say known quantity was mass. So I can say mass is known. Molecules are unknown. So I'm comparing these two things. This is known, so I'll keep it on left hand side. I will keep it on right hand side. 44 gram CO2 contain Avogadro molecules. Unit 1 gram CO2 contain Avogadro. This number will go down. Avogadro by 44 molecules. And 11 gram will contain how much? If 1 gram contain this much, 11 gram will contain 11 times. 11 times Na by 44, which is Na by 4 molecules. Na by 4 molecules. If you want to further simplify it, 6.02 into 10 power 23 upon 4, which is 1.5 into 10 power 23 molecules. Okay, anything they ask you in the mole calculation, you can easily calculate from here itself. Okay, simple unitary method. Do not be scared of any particular question. Whenever you see a question, deal it by going to the depth of the concept. Simple. Let's move on to the next one. I want you to answer it in the chat box. What will be the mass of 5.6 liter of oxygen gas at STP? Hello, beta. Ramanandam. Beleda. What's your name, beta? Can you tell me the answer in the chat box quickly? 5.6 liter O2. How much weight will be there for that? How much weight will be there for that? So since they are talking about O2, let's write the mole concept of O2. 1 mole O2, meaning 32 gram is the molar mass. It will contain Avogadro molecules. Meghna, hello Meghna. It will contain Avogadro molecules. Since they are not talking about molecules, they are talking about mass versus volume. I'll just mention the volume. It will occupy 22.4 liter at STP. 8 gram. Very good. Ramaditya, 8 gram. Very simple. It's correct. Absolutely correct. So 22.4 liter, in your mind you're thinking, sir, 22.4 liter weighs 32 gram. 22 ka 1/4 is 5.6 only. So 1/4 I did the volume 1/4. Automatically weight will also become 1/4. Both of them are extensive properties, volume and mass. If volume become half, mass become half. If volume become 1/4, mass become 1/4. Okay. Beta, I told this before as well. Thanks for asking again. Santhu Gaming. What will be the answer for the chemical kinetics NEET question? It will be, again, I told that time 3-4 times we have done the discussion on that. 0.75 is also correct answer. 1.5 also can be correct by thinking about what is that K. Okay. So we'll not go into that again. Let's talk about this particular one. So 1 mole O2 is this. So when I convert this 22.4 liter to 5.6 liter, I have 1/4 the volume. So automatically mass also become 1/4. Unitary method says 22.4 liter weighs 32 gram. 1 liter would weigh 32 by 22.4 gram. And hence 5.6 liter would weigh 32 by 22.4 into 5.6 gram, which comes out to be 8 gram. Simple. Right? 8 grams. Now let's increase the level a bit. Let's go to a little tougher type of questions. Right. Question is, 1 mole of nitride carries a total electronic charge of 3 Faraday. They will not tell you this. Okay, they will not tell you this. This first line I am removing. We'll solve the question without the first line. Calculate total charge in coulombs carried by 4.2 grams of nitride ions. Now let's not talk about only volume, weight, moles, where you can use formulas also. Let's talk a little depth about the charges. Beta, please remember, when you look at one nitride ion, N3 minus, if I take a single ion, 1 ion of nitride, okay, its net charge is not 3 coulomb. Its net charge is 3 unit charge. So its charge is 3 E. Charge on each electron is 1 electronic charge. Nitride has 3 negative charge, means 3 extra electrons as compared to proton. 3 electronic charges are there. So each ion has 3 E charge per ion. I hope it is clear to everyone. Okay. Now, if I write its mole concept, I will say nitride, 1 mole nitride, 1 mole of nitride, right? What will be its weight? Because question is giving you weight. So I will write its molar mass, which is going to be 14 gram per mole. So 1 mole nitride weigh 14 gram because nitrogen ka molar mass is 14 gram. Same way, nitride has just some extra electrons. Electrons will not contribute anything to the mass. still 14 gram. It will contain Avogadro number of particles. Here the particles will be called as ions because nitride is an ion. Okay. Now, each nitride has 3e ka charge. So, Avogadro nitrides have how much charge? Each nitride pe -3 charge is there. If 2 nitrides are there, -6e charge will be there. If 3 are there, -9e charge will be there. If Avogadro number are there, so 3e times Avogadro charge will be there on 1 mole. So, it will be the charge, it will be 3e times Na charge. And please remember now, when you multiply electronic charge with Avogadro number, this means charge on 1 mole of electrons, which is always coming out to be 1 Faraday or 96,500 Coulomb or 1 Faraday. 1 Faraday. So I can also say it carries 3 Faraday charge. So please remember this. One nitride doesn't have a 3 Faraday charge. One nitride has 3e charge. 3e. Okay, 1 mole nitride has 3 Faraday charge. So now we can solve this question. 14 gram has 3 Faraday charge. So by unitary method we say 14 gram nitride carries 3 into 96,500 Coulomb charge. 14 gram ke liye to I know. I have to find for 4.2 gram. 4.2 gram. 4.2 gram meaning how many times we have divided the 14, you can check. So 1 gram nitride will contain 3 times 96500 Coulomb divided by 14. And for 4.2 gram, it is going to be 3 into 96,500 by 14 into 4.2. Okay. 14 fours is what? 14 3 times is what? 14 3 times is 42. 14 thrice is 42. Okay. So it is exactly going 3 times. So I'll write at 0.3 times. So it is coming out to be 0.9 Faraday. 0.9 Faraday as the answer. If you want to convert it to coulombs, just multiply it with 96,500. 0.9 into 96,500 Coulomb. Okay. Around 90,000 something Coulomb will come. 92,000 Coulomb or so will be your final answer. Okay. So this is the one about this question of finding the charge. Let's move on to the next one now. Same question, another one. Determine the number of aluminium ions present in a sample which carries a total electrical charge of 0.6 Faraday. I want you to solve it. Give me the answer in chat box. All of you, give me the answer in chat box. How many aluminum ions are present in a sample which contain 0.6 Faraday charge? I am waiting for you. I'll wait for 1 minute and I'll come and solve it. How many aluminium ions are there? Give me the answer in form of Na, Avogadro number. Anyone? Tell me. Ram Aditya, Santhu Gaming, Meghana, or Rahitya, Shalini, anybody there? Lavanya. Is the answer coming out to be 2 moles, 2 Na? Is it 0.2 Na? Is it 2 Na? Is it 0.2 Na? Is it 0.1 Na? Is it 0.2 only? How many aluminium ions are there? Let us see. So if I write the mole concept of aluminium plus 3, I can say 1 mole Al plus 3, meaning Avogadro ions. And each aluminium plus 3 has 3 E charge. 1 mole will have 3 F charge. I just told you, 3 Faraday charge. Right? 1 mole of electron have 1 Faraday charge. 1 mole of aluminium has 3 times electron ka charge, so 3 Faraday charge. So 3 Faraday contain Na ions. 3 Faraday charge is there on Na ions of aluminium. So 1 Faraday charge will be there on Na by 3 ions of aluminium. And 0.6 Faraday charge will be there on Na by 3 into 0.6 ions, which is 0.2 Avogadro ions. So answer will be second option. Okay, so this is the one. Yes, very good, Aditya. Aditya Honey 5510. What's your name, beta? Is your name Aditya only? Good, that's correct. I hope it is clear to everyone. I want you to answer it if you are watching the video, if you're liking it. Please hit the like button as well, so that we also get more confidence on giving more and more classes to you. Otherwise, if viewership is less or you don't reply back, then it doesn't make much sense. If you reply back, we'll feel more motivated to come back tomorrow also, day after tomorrow also, almost every week 2-3 times to tell you new concepts like this, to relate different chapters with single concept like this. Right. Next one, bache. Now let's go to the next topic and use our unitary method for stoichiometric calculations. Stoichiometric calculations. Many students are, scared of doing questions of mole concept, stoichiometric calculation from, limiting reagent and all these questions. I have taken very simple question for you. How many grams of water will be formed by completely burning 4 grams of methane? Just unitary method. First thing is, whenever you write any equation, first thing always balance it. So it's already a balanced equation. 1 mole of methane react with 2 O2 to give 1 CO2 plus 2 H2. Okay. Unitary method. When I look at the stoichiometry, it says 1 mole methane provides us with 2 mole water. That's what the stoichiometry says. 1 mole methane gives us 2 mole water. You are allowed to compare anything with everything. Means you can compare mass with mass, mass with volume, volume with molecules, anything you can compare and tell the answer. Yes, Rahitya. Okay, that's correct, Rahitya. So 1 mole of CH4, I can write it as 16 grams. 16 grams. And 2 mole water, I can write it as 36 grams. Okay, meaning of 1 mole water is, 1 mole water is 18 grams, 2 moles water can be written as 36 grams. So I can say 16 grams of methane produce 36 grams of water. Now use your brain, use this unitary method, that's correct right there. 16 gram give 36 gram. If I make it 1/4, it will become 4 gram. I will have to make 1/4 that also. That will become 9 gram. That's correct. 9 gram is correct. 16 gram methane produce 36 gram water. 1 gram methane would produce 36 by 16 gram water. And 4 gram methane would produce 36 by 16 times 4, which is 9 gram of water. 9 grams of water. That is absolutely correct, and that's good that you have done it correct. See the next one now. Let's change the question a bit. In this reaction mixture contains excess of hydrogen and 0.5 moles of nitrogen. Question I am asking is, what volume of ammonia is produced at STP? What volume of ammonia is produced at STP? Okay, let's say this is the question. If the reaction mixture contains excess of hydrogen, means don't listen to hydrogen, it is excess. Always the reagent who is lesser in amount will decide how much product will form. Always the limiting reactant decides how much the product will form. It's not the excess reactant, it's always the limiting reactant. Let me give you an example for this. All of you would know the concept of limiting reactant. If not, you see here, limiting reagent, the one who finishes the earliest. The one who finishes the earliest. Okay, right there, that's correct. The one who finishes the earliest. Like for example, and every product will be decided by limiting reagent. Product formed is decided only by limiting reagent. Okay, very simple example. Let me say that to make a sandwich, we use 2 bread slices and 1 cheese slice to make a sandwich. Right. Let's say in your kitchen, bread slices to are available 18 bread slices you have in the kitchen. 18 bread slices you have in the kitchen. Available bread slices are 18. And cheese slices available are, let's say, 5. Question is, how many sandwiches can be formed? How many sandwiches can be formed? Right? So in such cases, what you do is, whenever the data of both the reactant is given to you, you don't know which will finish first. So you can, if I do it by very layman language, I can just say that 18 breads and 5 cheeses. If I draw the 18 breads here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. These are the 18 breads that I have. And I have only 5 cheese slices. Let me draw the 5 cheese slices. First cheese slice, second one, third one, fourth one, fifth one. When you start making the sandwiches, these 2 cheese slices, these 2 breads will combine with this cheese slice, you will get 1 sandwich. These 2 will combine with this one, you will get second sandwich, third sandwich, fourth sandwich, fifth sandwich. After these 5 sandwiches, cheese got finished. That means no further sandwiches I can make. So sandwiches will be formed only 5, which only depended on cheese. When you started making the sandwiches, cheese became 0 after some time. Still, breads are left. How many breads are left? 1, 2, 3, 4, 5, 6, 7, 8. 8 breads are still left. And by the time 5 sandwiches are made, and product formation stopped after this. So same way, whenever you are doing any reaction, always make the products based on who is the limiting reagent. How to find the limiting reagent also will be taught in the later classes. For this question, it's a simple question. They already told you that hydrogen is in excess. So nitrogen will make the product. 1 nitrogen make 2 mole ammonia. 1 make 2 mole ammonia. Half mole will make 1 mole ammonia, which is 22.4 liter. Correct right there. Let's move on to the next one. Right. Now let's see how electrolysis, the complete electrolysis topic, you don't have to remember any Faraday's law. Okay, any of the Faraday's law, you don't have to learn Faraday's first law, Faraday's second law, not required at all. directly we can use unitary method. Just basic reaction you should know, how the products get deposited at cathode or at anode. Let's see this question, everyone. During the electrolysis of copper solution, means it has to be a copper sulfate solution. If a current of 0.5 Faraday is passed, what mass of copper will be deposited at the cathode? We note that in copper sulfate, copper is present as +2, copper +2 aqueous. Cations go to cathode. At cathode, reduction happens. So this cation goes to cathode, takes up 2 electron, become copper solid. Meaning is 1 mole copper +2 react with 2 mole electrons to give 1 mole copper. Simple. I can say 1 mole copper +2 react with 2 mole electrons to give 1 mole copper. I can easily compare charge with the mass now. I can say 2 mole electron meaning 2 Faraday charge. Each mole electron has 1 Faraday charge. 2 mole electron means 2 Faraday charge. And 1 mole copper would weigh 63.5 gram. 63.5 gram. That's all finished. 2 Faraday can deposit 63.5 gram copper. 0.5 Faraday can deposit how much? 1/4. 2 Faraday ka 1/4 is 0.5. 63 ka 1/4 will be some 17 gram, 18 gram like that. So we'll say 2 Faraday deposit 63.5 gram copper. 1 Faraday shall deposit 63.5 by 2, and 0.5 Faraday must deposit 63.5 by 2 into 0.5, which is 63.5 by 4, which is almost a 16 gram, I can say. Almost 16 grams of copper will be deposited. 15.8. Yes, right here, that's correct. 15.8. Okay. So this is the way to solve. Now let's see one more problem here related to Faraday's law only. Question can be asked like this. Let's say 96.5 ampere current pass through KMNO4, K2MNO4, or let's take pass through Cr2O7 2 negative aqueous solution for Cr2O7 2 negative aqueous solution for 200 seconds. Find moles of K2Cr2O7 2 negative, Cr2O7 2 negative. Find moles of Cr2O7 2 negative which get reduced to chromium +3 aqueous. Okay, there is no need of any, that's correct Shalini, there is no need of any formula for this. Don't require any Faraday's law. Just simple unitary method. Simple unitary method will be used for this as well. Understand the question, bache. Understand the question. Some current, I value is given, is passed through dichromate solution for 200 seconds. Time is given. Find the moles of dichromate which get reduced to chromium +3. So they are saying do a reaction. Cr2O7 2 negative want to get reduced to chromium +3. In the redox reaction chapter, you study about balancing of half reactions. So this is a reduction half. Chromium is present in +6 oxidation state here. It wants to go to +3. Since there are 2 chromiums, I'll write 2 chromiums here for you. Each chromium going from 6 to 3 has to gain 3 electrons. So 2 chromiums going from 6 to 3 will have to gain 6 electrons to reach here. Okay, 6 electrons to reach here. First of all, I have written how many electrons are required to be gained by per mole of dichromate. Now I'll balance the oxygen. Next is balancing of oxygen. Wherever oxygens are less, that many water we add. This side 7 oxygen, so I will add 7 water here. And wherever the hydrogens are less, that many protons we should add. So 14 protons will come here. This is how the reaction looks like. Okay. So balancing of reaction must be clear to us before we do any of the unitary method question, because without balancing, unitary method cannot be applied. Now we can easily say what is known to you. For us, charge is known. Charge is current into time. We are passing 96.5 ampere for 200 seconds. So this much coulomb charge is there. 96.5 into 200 coulomb. Okay, this much charge is passed. Now, simple unitary method. When this person is 1 mole, he consumes 6 Faraday charge. 6 Faraday, I hope all of you are clear with. I can write as 6 into 96500 coulomb charge. Now, charge is known to me, so I'll keep charge on the left hand side. So I will say when 6 into 96,500 coulomb charge is passed, then 1 mole dichromate get reduced. When 6 into 96500 coulomb charge is passed, 1 mole dichromate gets consumed or get reduced. Finished. How much charge I have? This much. So when 1 coulomb charge is passed, 1 mole by 6 into 96500 mole get reduced. And when 96.5 cross 200 coulomb, this much charge is passed, so this value will get multiplied on the top, 96.5 into 200 by 96500 into 6. These many moles of dichromate get reduced. That is your final answer. So this will go 96.5, this will go 1000 times. This will go 0.2 times. So we get 0.2 by 6. 0.2 by 6, which is 0.033 moles. Or you can just call it as 1 by 30 moles. 1 by 30 moles. Not a tough question, just unitary method. We can do Faraday's electrolysis questions as well using just the basic unitary method. Okay, I hope it is clear to everybody. Moving on to the next one. This is a simple one. If possible, just you can read the question, take a screenshot and tell me the answer in the chat box later. Moving on to the next one. A solution of AgNO3 is electrolyzed using a current that provides total charge of 9650 coulomb, depositing this much silver. What mass of silver will be deposited if current setup was giving you some other charge? It's also a simple question, same type of question, just they are doubling up the amount of current. So amount of silver will also get doubled up. Okay, a simple question, this one as well. Again from the aluminium, same to same questions, I have taken few of them. Now let us see how chemical equilibrium question can be solved by unitary method. Chemical equilibrium question can be solved by unitary method. Reaction is given, let's say A gives B equilibrium. A gives B at equilibrium. It's a homogeneous gaseous reaction. Starting with an initial concentration of A as 4 mole per liter, the equilibrium concentration of B was found to be 2 mole per liter. Was found to be 2 mole per liter. What will be the equilibrium concentration of B if the reaction started with 12 mole per liter? If instead of starting with 4, if I start with 12 mole per liter, then what would be the new equilibrium concentration of B? Although it has simple unitary method problem only, it is not a tough problem. We can make it a little tough. First, I will tell you what to do here. So we can see 1 mole of A gives 1 mole of B. Whenever you're doing an equilibrium question, as NCERT tells you nicely, always write a RICE next to it. Reaction, initial, change, equilibrium, RICE. Just write the RICE next to it and then start your problem. It's again unitary method only we are doing, nothing new. But write a RICE. R means reaction, I means initial concentration, C means change in concentration, E means equilibrium concentration. Initial concentration was 4 mole here, it was 0 here. Initially, if I start with 4 mole of A, at equilibrium B was found to be 2. So at initial this was 4, this was 0. Now you think if one of this break, then one of this will form. So if I say X of A will break, X of B will form. So change in the A is minus X because A is breaking and B is forming. So it is remaining 4 minus X and B is remaining 1X. Simple. And for this we can say now equilibrium concentration of B is found to be 2 mole per liter. So X value is given 2. X value is given 2. So if X value is given 2, this becomes 4 minus X, which is also 2. That means equilibrium constant, which can be written as concentration of B at equilibrium to the power stoichiometry by concentration of A at equilibrium to the power stoichiometry, which is 2 power 1 by 2 power 1, 1. Since we know equilibrium constant always remain constant if temperature is fixed and the reaction stoichiometry is fixed. Now do the reaction once again. A gives B. This time RICE, we start with 12 moles per liter. This is 0. Let's break it Y. This will form Y. This should remain 12 minus Y. This should remain Y. Although we can easily say equilibrium constant is 1, so reactant and product must be equal for this equation. So we should make it equal. So 12 minus Y and Y is remaining. Okay. And now we can say, putting it into the equilibrium constant again, K equilibrium is still 1, which will be product, which is Y, by reactant 12 minus Y to the power 1 to the power 1. So we get 12 minus Y equal to Y. Y equal to 6 mole per liter. So answer will be, the new equilibrium concentration of B will be 6 mole per liter. 6 molar. Okay, 6 molar. Now I want you to do one question for me here. Okay, one question I want you to do. Question is, for the reaction N2 plus 3H2 give 2NH3. Starting with 28 gram nitrogen and 6 gram hydrogen in a 1 liter vessel. At equilibrium, weight of ammonia formed was, at equilibrium, weight of ammonia formed was let's take it as 8.5 grams. Find equilibrium constant Kc. Okay, think of this question, do it yourself. I'll give you 2 minutes time for this. Let's see how many give me the correct answer. Just basic unitary method also here we are using. Finally, we'll be just putting in the values in the equilibrium constant expression. So do this. This is the last question we'll be doing today. I'll wait for your answers. Equation is given, equilibrium constant for this same equation is asked to you. 28 grams of nitrogen is taken initially, 6 grams of hydrogen is taken initially in a 1 liter vessel. And at equilibrium, weight of ammonia is found to be 8.5 grams. Write Rice reaction initial change equilibrium. Write the initial concentrations of N2 and H2. According to their stoichiometry, you can break them in the same ratio of stoichiometry. Nitrogen will break 1x, hydrogen will break 3x, and ammonia shall form 2x. And then continue. Let us see now. I hope that you are also getting the answer for this the same way. So I'll write Rice. Reaction, initial change, equilibrium. Initial concentration. Nitrogen is 28 gram. 28 gram means 28 by 28, 1 mole. Initially, nitrogen was taken 1 mole in 1 liter. So 1 by 1. 64 by 27 right there. Let us see. 1 by 1. Hydrogen we took 6 gram. Molar mass is 2. So 3 mole. 3 by 1. So 3 by 1 and 1 by 1. What I have done here is I have found the moles and divided by the volume. So moles of nitrogen taken is 1 mole per liter. Hydrogen is 3 mole per liter. Ammonia is 0 initially. Then let's change it. According to unitary method, when this break 1, this should break 3, this should form 2. When this break 1x, this should break 3x, this should form 2x. So what we are remaining with is 1 minus x molar remaining, 3 minus 3x molar remaining, and 2x molar formed. These are their concentrations formed. Now they say at equilibrium, ammonia was found to be 8.5 grams. So I'm just checking the concentration of ammonia at equilibrium, which will be moles of ammonia at equilibrium by volume, which is 1 liter. Moles are 8.5 gram by molar mass of ammonia, which is 17 gram. Molar mass of ammonia 17 gram by volume is 1. 1 by 2 moles are given. 1 by 2 mole ammonia is formed. Okay, 0.5, which is 2x here. So this value of 2x is given 0.5. So x comes out to be 1 by 4. X comes out to be 1 by 4. So we'll put the value of x now. So from here, concentration of nitrogen comes out to be 1 minus 1 by 4, which is 3 by 4 molar. Concentration of hydrogen comes out to be 3 minus, so I can write as 3 times 1 minus x, and x value is 1 by 4. So it is coming out to be 3 times 3 by 4, which is 9 by 4 molar. 9 by 4 molar. And this is coming out to be 2x, which we already know. It came out to be half mole per liter, which is 2x. 2x ka value only was 0.5, so it was half mole per liter, 1 by 2. Right. So now we can write equilibrium constant. First, always write the expression of equilibrium constant, which is concentration of ammonia square by concentration of nitrogen power 1 hydrogen cube. Ammonia square can be written as 1 by 2 ka square, 1 by 4 divided by 3 by 4 power 1, 3 by 4 power 1, and 9 by 4 whole cube, 9 by 4 whole cube. So what we see here is 4 and 4 cancel out. 4 and 4 cancel out. So we get 4 cube going up, 64 by bottom 3 into 9 cube. 3 into 9 cube. I think you've done a mistake, Rahitya. Rahitya, have you seen your mistake, bache? At the bottom, there is 3 into 9 cube. 3 into 9 cube. So answer is coming out to be 64 by 3 into 9 cube. You can do the calculation of this part. So you are getting 64 by, right here you've written 64 by 27. It's actually 64 by 27 into 81. If this is the one, this is the correct expression. 64 by 27 into 81. Okay. So that was the mistake. So this is our answer finally. You can do the calculation part. It's not a difficult thing to do. So we'll keep it till here. I hope it is clear to every one of you and you have seen how unitary method can help you to solve questions from different topics. So I'll keep it till here. I hope you have enjoyed. Thank you very much. Take care. And I hope that those who have not scored, according to your own will, taking 1 year more is not at all a bad, decision. It's a very good decision. Scientific things take time. Becoming a doctor takes time. So if your time did not come this year, it will surely come next year. It doesn't depend much on the, teachers, or doesn't depend much on, on the environment. It mostly depends on your willpower. If you have the willpower to, achieve, you can achieve whatever you want. Nothing will go against you if you are having the willpower to achieve whatever your goal is. So I would say you are big enough now. You can take your own decisions yourself. So whatever thing you want to decide in life, whether you want to become a doctor or whether you want to choose any other course, take your decision yourself. You're already now 17 to 18 years of age. You're already entering the adulthood. So I hope you will be taking the decision quickly, Rahitya. I hope to see you soon, Rahitya. You have got good marks. I know your marks as well. So wait for the cutoff and let's see. Meet you all very, very soon. Okay. Come and meet in the campus whenever you wish like. Okay. Chalo. Thank you. Bye-bye. Take care. It was nice meeting you.